Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, Gaurav. So this whiteboard is visible to everyone?
Yes, sir.
Okay, great. So we are going to define a new notation which is called covering relations. Okay? Covering relations. So let me give you its definition. So this is the definition, if you can read. So P is any partially ordered set, right? Poset. P is any partially ordered set and X, Y are any two elements in P. We say that X is covered by Y or Y covers X, and we denote it by this X arrow Y or Y covers X. If X is related to Y, X is not equal to Y, and there does not exist any Z between X and Y. Okay, there does not exist any Z which is not equal to both X and Y, and it is X is related to Z and Z is related to Y. Such a Z does not exist. So if such thing happens, then we say that X is covered by Y or Y covers X. Is this definition clear to everyone? And we will say that X is covered by Y or Y covers X. Is it fine?
Yes, sir. Yes.
Okay, great. Good. So now we have a result based on this definition. Simple result, obvious result. So let P be a poset, P be a finite poset. Okay, so P is finite. P be a finite poset and let xy belongs to P. Then x is strictly less than y if and only if there exists a sequence of covering relations there exists a sequence of covering relation x is related to x is covered by some x1, x1 is covered by some x2 and so on, and then it is covered by some xn and this is covered by y. Okay, so we can find such elements x1, x2, xn belonging to P such that they lie between x and y. Fine. So can anyone suggest how to prove this? इंट्यूटिवली क्या लग रहा है, क्या होना चाहिए, इसे एग्जिस्ट करता है? या इसको हम इस तरह से लिख सकते हैं, xn is equal to y and x is equal to x naught. Yes. Will there exist such a sequence? और कैसे शो करोगे? X. So suppose it is obvious. Suppose X is related to Y. To show there exists a sequence of to show there exists x0 sorry x1 x2 xn x1 x2 xn belonging to P such that x is equal to x0 x1 x2 xn equal to. So how to show this? Yes. तो how you will show this? कैसे प्रूव करोगे इसे कोई? अच्छा ये कैसे प्रूव करोगे कि कोई भी अगर तुम्हारे पास सेट ऑफ कोई ये चलो इसका प्रूफ बताओ मुझे इसका सोच के बताओ. If there is some let S be finite subset of n, show that S be any subset of n, show that S has least element. कैसे इसका प्रूफ सोच के बताओ कैसे करोगे इसे? सेम लाइंस पे आएगा उसका भी प्रूफ. कोई भी सबसेट है एस एन का तो उसमें लीस्ट एलिमेंट होगा. यस. बताओ कोई सिंपल प्रूफ है इसका. यू कैन देखो कैसे प्रूव करोगे. यू पिक एनी एलिमेंट एक्स. ठीक है. लेट एक्स बिलोंग्स टू एस बी any element. If x is smallest then we are done, right? हमारा काम बन गया x एक smallest element अगर x is not smaller then there exists some x1 which is less than x such that x1 belongs to S. If x1 is smallest, we are done, right? If x1 is not small, then there exists some x2 which is less than x1, right? So continuing like this, we will come to a stage where this will
Is it well ordering principle?
It is not well ordering principle, or you can say it is well ordering principle. Every set of subset of natural numbers has a least element because it is bounded below. So we are not, but we are not going to use that fact. Okay. We are just going to use the fact that there are at most x element in this set S, which are smaller than x, right? So we are going to use the finiteness property here. Well ordering principle comes from the boundedness property, right? That it is bounded below, so it should have a least element. Proof is similar. Proof is similar to that also, because then you will say that it is bounded below, so it should have some number which is the smallest, right? So when you will continue like this, then you will, because this can have at most, this is the subset of natural numbers, so there can be at most x number of elements which are smaller than x, right? In fact, x minus 1.
Yes.
So this will end in a finite number of steps. So you will be able to find at some stage some xn which is the smallest, right? So same proof will apply here also. Okay, we will apply the same proof here also. Now, so first is if y covers x, right? If, then we have nothing to prove, right? This will be our x0, this will be our x1. So कवरिंग रिलेशन का एक चेन मिल गई हमें, राइट? सीक्वेंस मिल गई जिसमें दो एलिमेंट्स हैं x0 और x1. Now if x is not covered by y, then there exists z belonging to p such that x is smaller than z and z is smaller than y, right? Is it right? So z मत बोलो इसे. Okay, so z. So if x is not covered by y, then there exists some z which lies between x and y. So now what we will do, we will let x not be the smallest such possible element, x not be x1 because x not is our x, be the smallest such possible element in P. Okay, we can choose the smallest element because P is finite. Since P is finite, so we can always choose smallest. जैसे अभी मैंने बताया ना. Okay. Right?
Yes, sir.
This is smallest. So x1 will be the smallest such possible element in P, and we can choose such x1 because P is finite. ये लिख लेते हैं. We can choose such x1 as P is finite. So now Now if x1 is covered by y, then x equal to x naught x1 y is the required chain, right? Is the required chain. Otherwise there exists x2 such that x1 is less than x2 sorry x2 नहीं यहाँ पे अभी w करो, फिर we will choose the, यहाँ पे बोल सकते हैं, ठीक है. So otherwise there exists x2 belonging to P such that x1 is covered by x2 and x2 is smaller than y. ठीक है. If x2 is covered by y, then x1 x2 y is the desired chain, is the desired sequence. ठीक है. So otherwise we will proceed inductively. Otherwise proceeding inductively as above. Otherwise proceedingly inductively as above क्या होगा? We will reach a stage where proceeding inductively we will find a sequence of covering relation x equal to x naught less than x covered by x1, x1 is covered by x2, x2 is covered by x3, and so on, and this is covered by xn minus 1, which is covered by xn, which is equal to y naught. This process terminates as p is finite, इससे terminate होता है. ठीक है. नहीं तो टर्मिनेट नहीं होता ना, फिर तो इनफाइनाइट से जब भी जा सकते थे कि कभी मिलता ही नहीं ऐसा कोई एलिमेंट जहाँ पे टर्मिनेट हो रहा हो ये. ठीक है. Hence the proof. Is the proof clear to everyone? कुछ नहीं करा हमने, वही जो सेम चीज की. अगर एक पहले हमने ढूंढा कि क्योंकि अगर कवर्ड बाय वाई है तो हमारा काम हो गया, ये चेन अपने आप में बन गई. अगर नहीं है तो हम एक स्मॉलेस्ट ले लेंगे, तो स्मॉलेस्ट जो होगा फिर वो कवर करेगा एक्स को, क्योंकि उसके नीचे कोई नहीं आ पाएगा बिकॉज दैट इज द स्मॉलेस्ट. सो इस तरह से हम कंटिन्यू करेंगे. अगर x1 is covered by y, then we will stop because this will be the desired chain. अगर नहीं होगा तो again there will be some x2 such that x1 is covered by x2 and x2 is smaller than y. If x2 covers y, then we are done. Otherwise we will proceed inductively, and since our p is finite, so this process will stop, so we will be able to find a sequence of covering relations such that this is there. Is it fine, everyone?
Yes.
Sir, on the
Yes.
first page, sir, you write if x covers y.
Yes.
Sir, here.
हाँ.
If x, sir,
अच्छा,
next
this
line to this line.
does not, तभी एग्जिस्ट करेगा ना ये.
Yes, sir, I want to know this.
ठीक. पॉजिटिव केस, दो केसेस देते हैं, तो होगा या नहीं होगा. तो यहाँ पे हो गए वाले केस में दिस इज देयर, देन इफ नॉट देन सो वो गलती से आई मिस्ड इट. ओके, गुड. तो अब व्हाट नेक्स्ट? सो दिस इज डन. So now let give me some example ओके, एग्जांपल्स कर लेते हैं, एक दो सिंपल एग्जांपल्स। इन चेन एन दिस इज यूजुअल लेस देन इक्वल। अगर ये मेंशन नहीं है यूजुअल लेस देन इक्वल टू, दैट मींस इट इज अ यूजुअल लेस देन इक्वल टू, राइट? ठीक है, सो बाय डिफॉल्ट इट इज ऑलवेज यूजुअल लेस देन इक्वल टू अदर अनलेस इट इज मेंशनड। सो इन चेन दिस n is covered by m if and only if कब होगा? m की क्या कंडीशन होगी? What can you say about
m
m?
equals to n plus 1.
Yes, बस कंजेक्टिव टर्म ही तो वो कर पाएगा ना कवर। So n m is equal to n plus 1, ठीक है। Second, if I take a power set, let x be any non-empty set and in the poset px with containment relation a is covered by b if and only, क्या कह सकते हो b के बारे में? Yes, when will be a covered by b? b के अंदर a से कितने एलिमेंट्स ज्यादा होंगे? इक्वल तो है नहीं क्योंकि, और रिलेटेड है तो कंटेंट है। सो हाउ मेनी एलिमेंट्स आर देयर इन b? मोर देन a। कितने
One
एलिमेंट्स
more
ज्यादा?
than n.
एक ही ज्यादा हो सकता है। अगर दो कर दिया तो, जैसे अगर b के अंदर a से दो ज्यादा है, if b minus cardinality of b minus a is greater than 2, suppose greater than equal to 2, so there exist two elements a b belonging to b minus a. So अब क्या होगा, you can make, so a is related to, properly related to a union a, and this is properly related to a union, या b कर दो बस बीच में, so b, ठीक है। so this is, so this implies b does not cover a, yeah, but we are given a is covered by b, so b minus a should be equal to 1, that is if and only if cardinality of b minus a is equal to 1, that is there exists b belonging to b such that b is equal to a union b, b minus, ठीक है, या इसको ऐसे भी लिख सकते हैं, that exists b belonging does not, it not belong to a such that b is equal to a union b, is it fine? So covering relation सबको समझ में आ गया? What about R? R में कैसे एलिमेंट्स कवर्ड होंगे? Let in chain R x is covered by y if and only if, क्या कंडीशन होगी? एक रियल नंबर दूसरे रियल नंबर को कब कवर करेगा? बताओ, what can you say about x and y? एक रियल नंबर दूसरे रियल नंबर के कब नेक्स्ट होगा? अब उनके बीच में कोई रियल नंबर नहीं होगा। Under what condition? दो रियल नंबर्स के बीच में कभी ऐसी सिचुएशन आती है कि कोई रियल नंबर ना हो?
No, sir.
No. No. So there does not exist any pair of elements which covers such that one is covered by the other. So in chain R we know which theorem is this? By density. We know by density theorem that between any two real numbers there are infinitely many real numbers. Hence, there does not exist any pair xy in R such that either x is covered by y or y is covered by x. ऐसा कोई भी exist नहीं करता है, ठीक है? Is it fine, everyone?
Yes, sir.
Now we are going to do diagrammatic representation of a partially ordered set. So how to represent a poset diagrammatically? Okay. Diagrammatic representation has its own importance because we can we can get a lot of information by just looking at the diagram of the partially ordered set. So it is always nice to have its diagrammatic representation. So let us. So we can represent a partially ordered set by following construction. Okay. So partially ordered set P can be represented diagrammatically using following configuration. Let me state the rules for you. So these are the rules. To each point x belonging to P, we draw a small circle. Okay. For each point, we draw a small circle, and then for each covering pair x, अगर कोई हमारे पास y है that covers x, then we draw a line joining x to y to x to y. ठीक है? And y is always placed above x. ठीक है? px is lower than py. Is it clear? In simpler words, let me write in simpler words. In simpler words, First rule is to each element in P is represented by a small circle. Okay, each element in P is represented by a small circle in the Cartesian plane. Cartesian plane means कि पेपर पे जो ड्रॉ करते हैं, हमारा पेपर भी कार्टेशियन प्लेन की तरह ही, इट इज a two-dimensional plane. So या कार्टेशियन प्लेन मत लिखो, कंफ्यूज हो गए. So by a small circle. ठीक है. And then second is, what is the second point? If x is covered, if x is covered by y, then we place the circle representing y above the circle representing x, and we join the two circles by a line. ठीक है. So एक x का सर्कल बनाएंगे और उसके हल्के से ऊपर, मतलब किसी भी साइड बना सकते हो, बट इट शुड बी slightly above the circle representing x, and when we join the two circles by a line, so like this is circle x, this can be here, so y, and we join it by y. ठीक है. और कोई z इसके बीच में नहीं लाई करना चाहिए, that is not there, which is not equal to x and y. ठीक है. तो बस ये दोनों rules are more important. ये third rule is, this rule is not that much important because we are not going to draw any point which, कोई z ऐसे में ड्रॉ कर देना जो इस पे लाई करता हो, कुछ नहीं होना चाहिए. ठीक है. बस इतना ध्यान रखना है कि अगर हम कोई भी लाइन ड्रॉ कर रहे हैं तो there should not be any point on that line. ठीक है. So this you can note, there should not be any circle on the line joining x and y. So these 3 points you have to remember to draw a poset. Okay, is it fine? This is called Hasse diagram. Such a diagram is called Hasse diagram. Such a diagram representing a partially ordered set is called Hasse diagram. Fine.
Yes, sir.
Okay, so let us draw some examples for it. So consider a partially ordered set. And so example, consider the following partially ordered set. So इसकी क्या डायग्राम बनेगी यहाँ पे? Here we have A is smaller than C, A is smaller than D, B is smaller than C, B is smaller than D. So how we can draw this one? So we have A, which one covers A? A को कौन कौन cover कर रहा है? C and D both, right? क्योंकि there is no relation between C and D. और B को भी C and D cover कर रहे हैं, ठीक है? So we और A and B में there is no relation. There is no relation between A and B. So generally whenever there is no element related, so we try to put them along the same line. उसको ऊपर भी रख सकते हो, ऊपर नीचे कुछ भी कर सकते हो, बट अगर रिलेशन है तो वो रिलेशन वाला जो जिससे रिलेटेड है वो नीचे वो ऊपर होना चाहिए. So this is our A. We can put B anywhere. So for now I am putting B along with A, and so this is A, this is B, this is C, and this one is D. Now A is, because C is covering A, so I can draw a line because there is nothing between A and C, and similarly there is nothing between A and D. So this way you can draw. So this is one diagram for this P. Okay. Another way is, what you can do is, you draw A, you draw C, you draw D. Now you can put B anywhere, but it should be lying below C and D. So that should lie below C and D. So we can do is, we can keep it here also. Now there is no relation between A and B, so we can put, it does not have any impact on how A is placed because there is no relation between A and B, but B should be lower than C and D because it is related. So we can have a drawing like this also. So both are legitimate Hasse diagram for P. ठीक है? Is it clear? So अगर not related है, so you can put them as parallel also. और मतलब इन दोनों के बीच में आपस में कोई भी फर्क नहीं पड़ेगा कि कौन कहाँ पे placed है. बट जिससे अगर related है तो उससे lower होना चाहिए. ठीक है, ये ध्यान रखना है कि if it is related to some element, then it should be lower than that element. ठीक है? Okay. What can you say about these diagrams? This is another set of diagrams for P. What can you say about these diagrams? One, two.
They are false. They are not Hasse diagram because sir, B is less than C and D,
Because
and
B
there is
is,
no relation.
yes, B is smaller than C. So what should happen?
B should be lower
B
than
should be lower than C. So both 1 and 2 are not legitimate Hasse diagram for P. In one, B is related to C, but B is placed higher than C, right? And in second, also A is related to C, but A is kept at the same level as C, right? So ये भी नहीं होना चाहिए. This should also not happen. अगर B C से नीचे भी होता तो भी A should not be in the same level as C. And what about in second?
Sir, in second, C is in between A and D and there is no relation between C and D.
Yes, C is not related to D, but there is a line between C and D. Okay, so this is not possible. So that's why this is also wrong. Fine. So now we will give you a Hasse diagram. Consider a poset whose Hasse diagram is given by, so this is its Hasse diagram. So what can you say about this? Write all the possible maximal covering relations, that is covering relations with maximum elements. Okay. Yes, so what can you say about this? क्या क्या आएंगे इसमें?
Sir, A covers B, B covers
Also,
E.
एक और क्वेश्चन लिख लेते हैं. Write all non-comparable. Write all the pairs of non-comparable elements. Right. All the pairs of non-comparable elements. Yes, first chain. Let us write the first. So first chain is, let us start with A. So A is covered by B. B is covered by D, right? And D is covered by F. ठीक है ना, क्योंकि D और F के बीच में भी कोई नहीं है, B और D के भी बीच में कोई नहीं है. So this is one chain and this is the largest chain. Okay, so now second chain. अब we can start with, again we can start with A. So A से A की सारी chain खत्म कर लो. So A has to go to B, then B can go to E. E is covered by G. ठीक है. There is another chain. A covered by B, B covered by D, D covered by So all the chains with A are done. Yes, all the maximal chains starting with A. Yes. Now we can start with C. So C से कितनी chain है हमारे पास? Is there any other chain? देखो नीचे नहीं आना कभी भी, जो भी लाइन चल रही है you cannot come back. So इतना ध्यान रखना है. कवरिंग रिलेशन में हमेशा ऊपर चढ़ना है. So C से तुम ऊपर जाओगे, so ऊपर जाके इधर तो नहीं है, you cannot come back here. So there is only one way, that is you have to go to G. और G के बाद you cannot come back. So बस this is the only chain that starts with C. So these are the only possible covering relations, right? Second, नॉन कंपेरेबल एलिमेंट्स कौन कौन से हैं यहाँ पे? पेयर्स बताओ.
Sir, FG.
FG, right?
This is the only pair which is not comparable.
No.
Sir, because
A and
A
C
is
is
less
also.
than C.
No, A is not less than C. There is no line joining A and C.
But sir, it shows above A.
अभी तो बताया ना कि you can place C. Here also A was not related to B, but we placed it above A. That's what I told you. You can keep it parallel also, you can keep it above also. If some element is related to some other element, then it has to be there should be some chain to that element, right? Because A is related to F, so there is a chain. So there is no relation between A and C. Okay.
Okay.
A is not comparable to C. Then पहले A से देख लेते हैं कौन कौन से हैं. So C, you can go to E. So E is comparable. All these elements are comparable with A. So बस only C is there that is not comparable with A. Now we start with B. अब B का देखो, B के साथ कौन कौन से हैं? C is not comparable. Then all other are comparable, right? B is not comparable with C क्योंकि you can go ऊपर चलते रहना है. So you can go to E, then you can go to G also. D is there, you can go to F also from B. So only C is not comparable. Okay. Now come to C. C के साथ कौन कौन से हैं? C, B तो लिख लिया है, A भी लिख लिया है हमने. E and G are comparable. C and D is not comparable, right? And C and F are also not comparable. C is not comparable to D. C is not comparable to F because you cannot come here. You cannot come to D and F. Now C हो गया, अब B कर लिया. Now you come to E. So E is not comparable to D and F because not comparable to D. E is not comparable to F. So E भी हो गया. अब D का आओ. D का हमने already लिख लिया. D is not comparable with. अच्छा पहले D करना है, चलो कोई नहीं. D is not comparable with E, already written, and D is not comparable with C. This is also done. So अब एक ही पेयर रह गया F and G, right? F is not comparable. So these are the pairs that are not comparable. Fine. जैसे हम अगर हैसे डायग्राम दिया हुआ है तो हम उससे स्टडी करके बता सकते हैं कई चीजें, और अगर हमें पोसेट वैसे रिलेशंस के टर्म्स में दिया है तो वी कैन ड्रॉ इट्स हैसे डायग्राम. इज इट फाइन?
Yes, sir.
Okay, now what should be the diagram for 2? Draw the Hasse diagram for following posets. first is 2, second is 3, third is 4. What should be Hasse diagram for 2? 2 क्या होता है?
2 points representing 0 and 1 and 1 line above 0.
Yes, and there should be line joining 0 and 1. 0, 1, and there is a line, right? This is your 2. What about second, third? So this is your 2. Yes, what about this? 3. So 3 है 0, 1, 2, and it is a chain. So इस तरह से होगा, ठीक है? And what about this? Yes, it has 4 elements, right? But it is a anti-chain. These are chains. It is anti-chain. Anti-chain में क्या होता है? No elements are related, so there is no relation. So you just have to plot this 0, 1, 2. No line joining any 2 points. So you can put like this also, और किसी भी कहीं भी place कर दो, ऐसे भी कर सकते हो, ठीक है? कुछ भी order, क्योंकि there is no, if the elements are not related, then you can place them anywhere you like. But generally हम parallel रखते हैं so that it looks nice, ठीक है? So is this clear? Is this fine, everyone?
Yes, sir.
Yes, sir.
So so how many posets can be there with 3 elements? Yes, 3 elements. What are the possibilities you can have? Draw the Hasse diagram of all the possible posets with 3 elements up to isomorphism. Okay, so same. Yes, बताओ 3 एलिमेंट्स हैं, उनको कैसे कैसे रख सकते हो? ABC है, suppose P is equal to ABC, तो what are the possibilities? दो तो ऑब्वियस हो जाते हैं, एक चेन और एक एंटी चेन, राइट? एक तो चेन ले सकते हो, एक एंटी चेन ले लिया और एक चेन ले लिया, What next? These are the only possible posets with, this is first, this is second, this is third, this is fourth. These are the only possible. You can check yourself. So ये तो anti chain हो गया, ठीक है. This one is anti chain. Chain हमेशा ऐसे ही दिखेगा, ठीक है ना. This is chain. यहाँ पे क्या है? So two elements are not related and it is related to third one. So ABC इधर हो गया ABC और इधर हो गया A is related to B but not related to C. इस तरह से, ठीक है. You can check. यही 5 possibilities बनेंगी, ठीक है. ये तुम्हें करना है. Draw the Hasse diagram for ठीक है पावर सेट ऑफ 1 to 3, ठीक है, with inclusion relation. Fine. So this you have to draw yourself. इसको ड्रॉ करके ग्रुप में भेज देना सबके सब, ठीक है. उसकी ड्रॉ करके फोटो लेके ग्रुप में भेजना, ठीक है एवरीवन. Fine. Which is enough for today. Time is also up. So anyone wants to ask any question? किसी को कुछ समझ ना आया हो, कुछ भी पूछना हो. Okay, so as there are no questions, so let us end this class. So bye everyone.
Thank you, sir.